welcome everyone to another video of data science series. In today's video, I'm going to discuss what is logistic regression modeling. First of all, this is the table of content. After this video, we will know how to perform logistic regression using Python and how to perform Poisson regression using Python. Now, what is regression? Regression is a statistical method used to understand the relationship between dependent variable, often called target, output, or predicted variable, and the one independent variable, often called predictors variable. The goal of regression is to analysis of the relationship between dependent and independent variable. Now, what are the applications of regression? It is used in predictive modeling, forecasting future value based on historical data. For example, using histograph, predicting sales, stock prices, etc. Risk assessment, evaluating the risk factors associated with the outcome. Example, credit scoring, insurance risk, credit score for, and also for credit, calculating credit score, and trend analysis, identifying the trends and the pattern in data over time. For example, analyzing the price of rice due to economic and climate data. Now, what is Poisson regression? Poisson regression is used for modeling the count data and contingency table. It assumes that response variable follows a Poisson distribution is typically used for count data where the outcome is non-negative, meaning it counts on a non-negative integer whether the count data is non-negative or positive integer. It is a form of linear regression but advanced. Let's look and take a look at logistic regression. Logistic regression is a statistical method used for binary classification problems. It, the, uh, it is generally used for classification of uh, suppose male, female, yes or no, pass or fail, and 0 and 1 for binary decision making. The output of logistic regression is a probability value between 0 and 1, which can be threshold to make binary decision. For example, 0.01 to 0.05 is a threshold value of our program. Regression using Python. Now import pandas is PD. We are including pandas library and sklearn library. From sklearn, we are importing train test split for splitting the data and logistic regression and classification report and accuracy to score as always and confusion matrix to draw the confusion matrix. We have gathered a sample data and we are converting it into the data frame and storing in a df variable called df, and we will split the data set x y x train y train test. This will split the data and then we will train the model based on these splitted values. Then I have created a object called model, and now I am fitting or transforming the data into the model. Now I'm storing the x text variables info or training data into the predicted value. This will predict. This will give us prediction value and store it in prediction variable. Our next step is to evaluate the model. As always, we will evaluate the model based on classification report and accuracy score. And this time we will include the confusion matrix too. Let's look at the output. We have classification report with the support of 1, 2, and 3. Now our accuracy is 0 as the data is null. Data is equivalent to fail the values of all training regression model, and we got a confusion matrix of 0, 0, 1 and 2, 0. Now, what is Poisson regression? With an example of Python code, we have included pandas library, numpy library, and states model API. We have given a random sample data and stored it in a data frame. First, we will pre-process the data based on the features of feature 1 and feature 2 and store it in x and y variable. Next, we will add the constant of x variables. This will add the terms which are constant onto the new x variable. Now, training the Poisson regression model. We'll be using SM as an estates model. This will include GLM method where sm.families.poison, meaning we are training the Poisson regression. This is the current syntax dot fit means meaning we are currently making a regression model and as well as transforming it also. Next, print the regression model means I am evaluating the Poisson model summary. Now let's take a look at the summary. Generalized linear model regression readers. Our model family was Poisson and log likelihood was 211. Let's take a date is wrong. Sorry guys, date is wrong. Okay, let's take a look at the coefficient values. We can see the coefficient, constant coefficient was 1.5 5 to 7, and the standard error lies between 0.11 to 0.15 and 16 almost. Means the error rate is between 11% and the 15 and to 15%, which is understandable but not appreciated. It must be under 10%. If you are working on a larger data set, it is acceptable. It is sometimes acceptable. That is it for today, guys. Thank you for watching. I hope you understand the Poisson regression and logistic regression.